Hi everyone. This is example 2 from chapter 14 from your student packet. It says, suppose the weights of college textbooks are normally distributed with a population mean of 4 pounds and a population standard deviation of 1.2 pounds. Suppose we randomly sample and weigh 16 textbooks. Answer the following questions. So for part A, it says, what is the probability that the sample average of the 16 textbooks is less than 3.5 pounds? So before I go into this question, I want to look at the distribution for the population and for the sample. So the population distribution, notice that it says that it's normally distributed and it has a mean of 4 and a standard deviation of 1.2. Now, because the population distribution is normally distributed, then for any sampling distribution of any sample size, that distribution will also be normally distributed. So the sampling distribution will also be normal, and it will also have a mean of 4, because remember that the sampling distributions has the same mean as the population distribution. And so it's the standard deviation that changes, and the sampling distribution standard deviation will be the standard deviation of the population divided by the square root of the sample size. And when you put this in your calculator, you'll get 0.3. So now for part A, it says, what is the probability that the sample average of the 16 textbooks, which means it's asking us to use the sampling distribution, and what is the probability that the average is less than 3.5 pounds. So we'll do normal CDF. Less than 3.5 pounds means the lower bound is negative infinity, and the upper bound is positive 3.5. The mean is the mean from our sampling distribution, which is 4, and the standard deviation is the standard deviation from our sampling distribution, 0.3. And when you put this in your calculator, you get a probability of 0.0478. Now for part B, it says, what is the probability that a given textbook weighs more than 5.5 pounds? Notice it's not talking about a sample average. It's talking about a single textbook, a given textbook, which means we're talking about what is the probability that a given textbook from the population is more than 5.5 pounds. So for this problem, we're not using the sampling distribution, we're using the population distribution. We're still looking for a probability, so we'll do normal CDF. More than 5.5 pounds means that the lower bound is 5.5 and the upper bound is infinity. I'm going to use a bunch of positive 9s. The mean of the population is 4, and now we're going to use the population standard deviation, which is 1.2. And again, it's because we're talking about any single textbook, not an average. And when you put this in your calculator, you get 0.106, or about 10.6%. For the bottom problem, it says, imagine the distribution of all the possible sample averages for size 16 samples of textbook weights. So again, we're back to talking about the sampling distribution for size 16. What is the weight that separates the lightest 25% of sample averages from the heaviest 75% of sample averages? So in this case, we're looking for the sample average that separates this area. So we're using the inverse norm command. And the inverse norm command for most calculators only works for the lower percentage. So in this case, it says the lightest 25%, so that's the average. I don't know why I have a colon there. I need a parenthesis. So we'll do 0.25. The mean is 4, and again, because we're talking about the sample averages, we're talking about the sampling distribution, and the standard deviation for the sampling distribution was 0.3. So when we put this in our calculator, we get 3.8. So this is going to be 3.8 pounds. So any sample average that is 3.8 pounds or less is going to encompass the lightest 25% of sample averages.